4 over x minus 3 over 2 is equal to 5 over x. And copy the solution now. 4 over x minus 3 over 2 equal to 5 over x, and put parentheses, and let's get the LCD. Now the 2x and multiply both sides by 2. Now 2 times 4, 8 x over x, and copy the signs, and 2x times 3 over 2 is 6 x over 2, and 2x times 5 over x is 10 over x. Cancel the x and get the 8 and sign, and 6x divided over 2 is equal to x3. 10x divided by x is 10. Now 8, arrange the equation, copy the 8 and equal to 10. Now the 3x is at the end. Now 8 minus 10 is negative 2, and copy the 3x and multiply by 3 and cancel the 3x. The answer is negative 2 over p is equal to x.
First, we want to get all terms on one side of the equation, so we subtract 5 over x minus 4 from both sides just to give us 5 over x minus 3 minus 2 over x minus 4 minus 5 over x minus 4 equals 0. Next, we combine the terms with the same denominator. The terms negative 2 over x minus 4 and negative 5 over x minus 4 combine to give negative 7 over x minus 4. Now our equation is 5 over x minus 3 minus 7 over x minus 4 equals 0. To combine the remaining fraction, we need a common denominator. The common denominator for x minus 3 and x minus 4 is x minus 3 times x minus 4. We will write each fraction using this common denominator. 5 x minus 4 over x minus 3 and x minus 4 minus 7 x minus 3 over x minus 4 and x minus 3 equals 0. Now, we combine the fraction into 1. 5 times x minus 4 minus 7 times x minus 3 over x minus 3 and x minus 4 equals 0. Next, we expand the terms in the numerator. 5x minus 20 minus 7x plus 21 over x minus 3 x minus 4 equals 0. We simplify the numerator by combining like terms. Negative 2x plus 1 over x minus 3 and x minus 4 equals 0. For a fraction to equal 0, the numerator must equal 0. So we set the numerator equal to 0. Negative 2x plus 1 equals 0. Now we solve for x. Add 2x to both sides. 1 equals 2x. Finally, divide both sides by 2. X equals 1 half. So the solution to the equation is x equals 1 half.
We start with the equation 2 over x plus 2 minus 3 over x minus 2 is equal to 6 over x plus 2. First, we want to get all the terms on one side of the equation. So we subtract 6 over x plus 2 from both sides. This gives us 2 over x plus 2 minus 3 over x minus 2 minus 6 over x plus 2 is equal to 0. Next, we combine the terms that have the same denominator, which are 2 over x plus 2 and minus 6 over x plus 2. Combining this gives us negative 4 over x plus 2. So now our equation is negative 4 over x plus 2 minus 3 over x minus 2 is equal to 0. Now we need to find the common denominator for two remaining fractions. The common denominator is x plus 2, x minus 2. We rewrite each fraction with this common denominator. Negative 4x times x minus 2 over x plus 2 times x minus 2 minus 3 times x plus 2 over x plus 2 and x minus 2 is equal to 0. We combine this into a single fraction. Negative 4 times x minus 2 minus 3 times x plus 2 over x plus 2 and x minus 2 is equal to 0. Next, we expand the terms in the numerator. Negative 4 plus 8 minus 3x minus 6 over x plus 2 and x minus 2 is equal to 0. We simplify the numerator by combining like terms. Negative 7x plus 2 over x plus 2 and x minus 2 is equal to 0. For a fraction to be 0, the numerator must be 0. So we set the numerator equal to 0. Negative 7x plus 2 is equal to 0. Now we solve for x. We add 7x to the both sides. 2 equals 7x. Finally, we divided by 7x is equal to 2 over 7. So the solution to the equation is x is equal to 2 over 7. To solve the equation, first, eliminate the fractions by multiplying all terms by 2x. This gives you 3x minus 1 plus 2x is equal to 10x. Simplify this to 3x minus 3 plus 2x is equal to 10x. And further, to 5x minus 3 it is equal to 10x. Then subtract by 5x from both sides to get negative 3 is equal to 5x. Finally, divide by 5 to solve for x, which give x is equal to negative 3 over 5. Check that this solution doesn't make any denominator.
We have the equation 5 over x plus 4 over 2 equals 3 over x. First, we simplify 4 over x. So the equation becomes 5 over x plus 2 equals 3 over x. Next, we want to get all the terms with x on one side of the equation. To do this, we subtract 3 over x from both sides, which give us 5 over x minus 3 over x plus 2 equals 0. Then we combine the fraction 5 over x minus 3 over x, which equals 2 over x. So the equation becomes 2 over x plus 2 equals 0. Now we subtract 2 from both sides to isolate the fraction, giving us 2 over x plus equals negative 2. To solve for x, we multiply both sides by x, which give us 2 equals negative 2. Finally, we divide both sides by negative 2 to get x equals negative 1. So the solution to the equation is x equals negative 1.
We start with the rational inequality negative 4 over x minus 3 less than 2 over x plus 1. First, we want to get all the terms on the one side of the inequality so we can compare the expression to 0. We subtract 2 over x plus 1 from both sides. Negative 4 over x minus 3 minus 2 over x plus 1 less than 0. Now, we need to combine the two fractions into a single fraction. To do this, we need the common denominator, which is x minus 3 times x plus 1. We rewrite each fraction with this common denominator. Negative 4 times x plus 1 over x minus 3, x plus 1. Minus 2 times x minus 3 over x minus 3 and x plus 1 less than 0. Now, we combine the numerators. Negative 4 times x plus 1 minus 2 times x minus 3 over x minus 3 and x plus 1 less than 0. Next, we simplify the numerator by expanding the term negative 4x minus 4 minus 2x plus 6 over x minus 3 and x plus 1 less than 0. Combine like terms in the numerator, negative 6x plus 2 over x minus 3 and x plus 1 less than 0. Now we need to find the critical numbers. These are the values x of the make 0 numerator of the denominator equal to 0. For the numerator, negative 6x plus 2 equals 0. X equals to 1/3. For the denominator, x is equals to 3. X plus 1 is equals to x equals to negative 1. So the critical numbers are these. Now we create sign chart to determine what intervals the inequality is satisfied. The intervals are Now we create a sign chart to determine the intervals where an inequality is satisfied. The intervals are first, infinite, negative infinite, and negative 1. Second is negative 1 and 1/3. Third is 1/3 and 3. And the fourth is 3 and positive infinite. We get that we want the intervals where the expression is less than 0. This occurs on the intervals negative 1 and negative 3 and positive 3 and positive infinite. Since the inequality is strictly less than, we do not include the values where the numerator is 0 in our solution. Therefore, our solution is negative 1 and positive 1/3 union positive 3 and positive infinite. These are x cubed minus 2x minus 10 over 1 minus x greater than 2. First, we write the inequality. The first step in solving any inequality is to get all the terms on one side so that we are comparing the expression to 0. This makes it easier to analyze the sign of the expression. Subtract 2 from both sides. X cubed minus 2x minus 10 over 1 minus x minus 2 greater than 0. And second, combine into a single fraction. To combine the terms into a single fraction, we need a common denominator. In this case, the common denominator is 1 minus x. So we rewrite 2 as a fraction with this denominator. X cubed minus 2x minus 10 over 1 minus x minus 2 times 1 minus x over 1 minus x greater than 0. Now, we can combine the fraction x cubed minus 2x minus 10 minus 2 times 1x over 1 minus x greater than 0. And then third, simplify the numerator next. We simplify the numerator by expanding and combining like terms. X cubed minus 2x minus 10 minus 2 plus 2x over 1 minus x greater than 0. And x cubed minus 12 over 1 minus x greater than 0. And 4 identified critical numbers. Critical numbers are the values of x that makes the numerator of the denominator equal to 0. These numbers are important because they divide the number line into intervals where the expression has constant sign. Numerator x cubed minus 12 equals 0. X equals 12. Denominator. Create a sign chart. A sign chart helps us determine the sign of the expression in each interval created by the critical numbers. We divided the number line into interval based on the critical number. Interval 1 is x less than 1. Interval 2 is 1 less than x less than 12. Interval 3, x greater than 3 and 12. Now we pick a test value from each interval to plug into a simplified inequality to determine the sign of the expression in that interval. Find the intervals where the expression x cubed minus 12 over 1 minus x is greater than or equal to 0 based on the sign chart. This occurs in the interval 1 greater than x greater than 12. We must also consider the critical number themselves. X equals 1, this value makes the denominator 0, so it must be included from the solution. X equals 12, this value makes the numerator 0, so the expression equals 0, which satisfies the inequality greater than 0. We include this value in the solution. Therefore, the solution is negative infinite and positive 1 union positive square root 3 and 12.